Okay, 9.5, solving nonlinear inequalities. So for, oops, that should be A. System of nonlinear inequalities is a greater than or equal, less than or equal to, we can identify regions where the solutions set for an inequality overlap, paying special attention to the points of intersection. So again, this is just going to be drawing a sketch of our graph and shading things in to find our solution region. So we're going to solve the system of inequalities. So our first inequality, that is a circle. So I have that information down here. So we have a circle. Our center is at the origin. Our radius is 3. And when we draw this in, this is going to be a solid circle because of the equal part of the inequality. And we're going to shade inside because it is less than. So less than, we're going to shade inside this circle. If you want to, you can pick a test point inside the circle, plug it back into the equation and see if it makes our inequality true, and then you know that's the part to shade. If you pick a test point and it's not a solution to the inequality, you know you're going to shade the other part, the outside. Our second equation is an equation of a line, so I went ahead and solved it for y. Linear y-intercept is b, which is 3. Our slope is down 2 over 1. Again, this is going to be a solid line because of the equal bar, and we're going to shade where the y values are less, which is to the left and down. So if you're a person that likes to shade in everything, let's go back to our circle, and we're going to shade on the inside of our circle. So everything in here. And then everything below our line would be all this space down here. And then again, our solution region is where it is double shaded, where we have both. So that was the original part of the picture. I'll go back here so you can see that. So they just, or my diagram just shows the double shaded region, which is our solution region. Now, just wanted to show you if this equation was slightly changed, or this inequality was slightly changed. So for example, if our circle had just a less than symbol, then our boundary would be dashed. So we would not include all points on the edge of our circle. So you draw that in dashed. Well, that would now affect the intersection points that we have with our line, and we would not be able to include them in the solution, so those would be open circles at our intersection points. So you just have to be careful with our inequalities of solid or dashed lines. Are we going to include the intersection points or not? So open circles if not.